This is Algebra 2, Lesson 5.6.2 on natural logarithms. Natural logarithms are written like this. Natural log of x equals y. It's the same or similar idea as our logarithms. It's just that it has a base e in this example. So natural logs, natural logs are written natural log of x. I don't know why they do ln instead of nl, but that's what they do. So natural logarithm is very similar, like I said, to our logs. Before we had log base b of a equals x, and we would convert that to b to the power of x equals a. Well, here, the assumed base in a natural log is e, where the assumed base in a traditional log is 10. So here, if you see natural log of x equals y, it's the same as rewriting e to the power of y equals x. So let me write that a little differently. If you see natural log of x equals y, if there's nothing written here, you can assume that it's base e. If it's anything except e, you should use a log, just a regular log, not a natural log. Then we would switch this or convert it to e to the power of x, to the power of y equals x. So it's very much the same where our bases become the bases, and the solo item becomes the power, and then the extra piece is just flying solo. So very much the same, except it says natural log instead. Natural log is often used with interest rates, like continuous interest, because e is roughly 2.7. You can Google it, it'll tell you roughly, but e is 2.7, just like pi is about 3.14. So to kind of make this a little bit more clear, if we had the square root of x, for example, and we wanted to solve for x, the inverse of a square root is to take that square root x squared, because then these chunga chunga, and we're left with simply x. And that's the whole goal, is to get x by itself, typically in algebra. So these two operations, squared and square root, are inverses. So if you start with natural log of x and you want x by itself, you need to take base e to get the x by itself. Similarly, if you have e to the power of x and you want just x, you need to natural log both sides. So you want to natural log both sides. Those two are inverses of each other. Base e and natural log are inverses of each other. So let's look at some examples, because right now it seems really complicated. So this says e to the power of 3 equals x. What we do for that one is we simply type in e to the power of 3 in our calculator. And what you want to press on the calculator is second ln, and that will pop up an e. And then you want to do 3. So here's what you hit. Patience is a virtue. So again, you hit second, and then here's your natural log. You see how there's an e in blue right there? That's why we hit the blue key first. So e will show up, 3, hit enter, 20.09. So this is 20.09. For this part B, we do 400 times e to the 0.07 times 3. There's a decimal in there. It's kind of hard to see, but on your paper it's a little more clear. So we can just type that into a calculator also. 400, and we want E, so we want this blue thing. Blue 0.07 times 3. Now if you have an older calculator, make sure you open parentheses for the exponent. Hit enter and we get 493.47. So those we just typed in. Okay, now these ones we have to do a little bit of work to isolate x or solve for x, but it's really nice. The inverse of base e is natural log. So if we natural log both sides, I can rewrite this. Students in class preferred I rewrite it. If we natural log both sides, these chunga chunga, and we're left with x equals the natural log of 8. When we type that in, we want just the regular natural log, so we don't press the second, we just press that, 8, and hit enter, 2.08. Okay, then we try the next one. In this one, we have to divide by 4 first. Chunga chunga, we get e to the power of x equals 6. And again, to isolate x, we need to natural log both sides. Then these chunga chunga, and we're left with x equals natural log of 6. Natural log 6, enter, 1.79. Okay.